What is the transparency? What is transparency in a DD DBMS? And briefly describe describe the three main types of transparency related to data distribution. Transparency is this separation of the higher yes semantic of a system from the lower level implementation. Implementation issues in a DD DBMS. The fundamental issue is to provide data independency independency distributed environment. This allows users and application programs to treat the distributed databases as a single centralized database, simplifying application development and maintenance. The three main types of transparency related to data distribution are second question is what is the fundamental role of transparency in a DDBMS and briefly describe the three main types of transparency related to data distribution. So transparency is separation of the high semantics of a system from the lower level implementation issues. Transparency is nothing but separation of higher semantics. If you have higher semantics of a system and we are facing some lower level implementation issues, okay, higher semantics of a system get separated from lower level implementation issues. Okay, in a DDBMS, the fundamental issue is to provide data dependency distributed environment. The major fundamental issue is nothing but we have to provide data independence in the distributed environment. That is the main issue. And this particular transparency allows users. We are having users, right? These users and the application programs. This allows users and application program to treat the distributed database as a single. It makes the particular user feel that this is not a distributed database. This is a single and centralized database. We are having distributed database, but by a user it appears like it's a single and centralized database. And this particular process simplifying application development and maintenance. When the users feel that it is a single decentralized database, so the application development for a developer and for the maintenance also it will be very easy. And now we are going to discuss about the three main types of transparencies related to data distribution. The first one is network and distributed transparency. Let me add a new page. This encompasses encompasses the shielding of users from the actual physical location of the data, location transparency, and how the data is partitioned or restructured across sites. Fragmentation. Fragmentation transparency. So this particular network transparency, this encompasses the shielding of users from actual physical location of the data. Okay. So this particular network transparency shields the users from actual physical location of the data, not only shielding the users not only shielding the users from the actual physical location of the data, and this is called as location transparency. The shielding of users from actual physical location of data is going to be location transparency. And we have another thing, how the data is partitioned or restructured across sites. So if you want to know how the data is partitioned or reconstructed across sites, that is called fragmentation transparency. Next, we're going to discuss about fragmentation transparency. This hides the fact that a relation may be divided into smaller fragments. Subrelations. This fragmentation can be horizontal, based on selection, like groups, or vertical, based on projection, like columns, or hybrid. Now we are going to discuss about fragmentation transparency. This fragmentation transparency hides the fact that a relationship may be divided into smaller fragments. So, always there will be a fact making that relationship, but this fragmentation transparency hides that this particular relationships are present in smaller fragments. It makes user to feel like a relationship between all the columns, but inside that particular distributed database we can able to see small fragments. This fragmentation, the fragmentation which we're discussing, can be horizontal. Fragmentation can be done horizontal based on selection, like rows, If you're selecting rows, horizontal fragmentation will be done. If it is based on projection, if this it is based on projection or like particular column values, okay, that is vertical fragmentation. They may be both fragment, they can be both horizontal and vertical. Then it is called as hybrid fragmentation. And next we are going to discuss about replication transparency. This replication transparency also hides the fact that copies fragments may be stored at multiple sites for improved reliability and performance. The DDBMS, the DDBMS manages these replicated copies, ensuring mutual consistency and freshness. Without user intervention. Okay. Now we will discuss about replication transparency. This hides the fact that copies of data fragments may be stored at multiple sites for improved reliability and performance. This particular replicate transparency feature hides the fact that the data copies fragmented, which were fragmented into small fragments. Okay, this particular matter will be hidden, and like that which are where they are stored at multiple sites for improved reliability and performance. Why we are fragmenting the data in multiple sites for having improved reliability and performance. And the like the DDBMS manages these replicated copies. So we are having some replicated copies, right? This DD BMS software will manages this replicated copies. This particular software ensures mutual consistency. Okay, if you if you run the particular query in multiple situation also, or like multiple like different queries also, it has to give you the same type of data. It has to give the same type of data for different situations also, and it has to ensure the particular column value same for each and every instance. And if you're making any update also, the particular recent data has to be shown. So it ensures mutual consistency and freshness. Freshness is nothing but even the data is updated also, the updated data has to be displayed. Here, this particular distributed database should not have user's intervention. So there will be no intervention from the user saying that uh, like uh, like giving some particular information to the particular system. Only user is meant for reading the information, not for giving any suggestion or giving any feed. Replication database uh, works without user intervention. Next one, define the components components of relation are in the relational model, and explain the difference between a relational schema and a relational instance. Answer: a relation are with attributes A is equals to A1, A2, and so on. An is defined over n domains d is equals to d1, d2, and so on dn. It is finite time varying set of n tuples angle D1, D2 and so on Dn. Range will be where Dn from domain. Awesome. Relation R. This is the tabular structure itself. Attributes. These are the tables. These are the table columns. Tuple. This is an n tuple representing a single row in the table. So define the components of relation R in the relational model and explain the difference between a relational schema and relational instance. So now let us define what is relation R. Relation R with attributes. Relation R with attributes. A is equals to A1, comma A2, comma up to 7 AN is defined over the n domain, that is D1, D2, so on Dn. So this is this relation between attributes A1, A2, so on An defined over domain D1, D2, so on Dn. It is finite time varying set of n tuples. Here the values are finite and the set will be time varying having n tuples, and we have angles also d1 d2 so on dn, and it ranges from di to dom I. And relation here, the relation R is tabular structure itself. We having tabular structure, right? The tabular structure itself will be relation R. So we are having table columns, right? Those are attributes, and we are discussing some tuples, like row values are there, no? There are n tuples representing single row in the table, that is called tuple. Single row present in a table will be called as tuple. Now we'll see difference between relational schema and relational instance. Now we'll start with relational schema. A relational schema is the definition of the relation which is essential set of its attributes A1, A2, so on An describes structure but contains no actual data. For example, employee, employee table, employee number, employee name, title, salary, mm, PF number, responsibilities, duration, work duration. This is an example for relational schema. A relational schema is a definition of the relation. So if you want to define relationship, so we are going to define it by using relational schema. So here we have few set of attributes. We have few set of attributes. These are essential. Those are A1, A2, so on AN. How we are going to describe relational schema? Let us see. We are going to describe in a particular structure, nothing but tabular structure. Okay, we are going to create a structure, but no actual data. We are not mentioning the row values. We are only drawing a table with the column names. Okay, let us show you how the particular what is going to be called as relational schema having only column values. Employee is the table name. Okay, inside the table I don't define the column, that is employee number, employee name, title, salary, PF number, and his responsibilities and duration he is going to work. Next, we are going to discuss about the relational instance. A relational instance simply called a relation. In some context, in some context is the actual content or snapshot of the data at a given time. It is a finite set of n tuples that is subset of Cartesian product of the domains of R attributes for the employee schema. The table containing the actual source of employee data is the relation instance. Now we will discuss about what is a relational instance. Relational instance nothing but relation in some context. We want to define the relation between a relation in some context in some context or some particular time. Okay, so we are going to mention what is the context, what is the purpose. If you are mentioning what is the purpose, that is relational instance. Okay, this particular relation instance can also be called as snapshot of the data. Snapshot of the data at a given time. In a given time, what is the data available with you? You can able to present itself by creating a relational instance. So here, relation instance is a finite set of n tuples. We have some finite set of tuples, that is subset of Cartesian product of domains. We have multiple domains in a particular like a database. Okay, each and everything is going to subset of one another. All attributes present in a subset. For employee schema, the table containing the actual rows of employee data. We are having the data with respect to employee number, employee name, like PF number, salary, like responsibility. These are the column headers, and actual thing will be relations instance. For each instance, what is the value of employee number, employee name, salary? This is the instance. So orally, this is the difference between relational schema and relational instance. Okay, so we will have a new topic in another video. We'll continue. We will continue discussion later in another video.